Hello, good morning, friends. Once again, a warm welcome for online learning in chemistry. Today, we are going to continue with solving more problems on empirical formula and molecular formula. Yesterday, we studied and solved one problem on empirical formula to find out empirical formula as well as molecular formula. Today we will continue with more examples and also we will go to the next topic today. So let me share the slide screen with you and we'll go to the PowerPoint presentation. So we have solved yesterday problem on empirical formula and molecular formula and we got the answer yesterday, that is CS2Cl. So today we'll continue with some more problems. So here, yesterday we solved the empirical formula, that is CS2Cl, and also we got a molecular formula, that is C2H4Cl2. So we'll go to the next problem today. Yeah, the problem is a compound with molecular mass 159 was found to contain copper 39.62, copper 39.62, right? Then sulfur 20.13 and it has a molecular mass of 159. So you have to find out what is the molecular formula. The given data is atomic mass of copper is 63 and that of sulfur is 32 and that of oxygen is 16. Now in short, this is a hint. When there is a data given, there are of three elements, that is copper, sulfur and oxygen. Atomic mass is given. But if you see, the percentage is only given of two elements, that is one is of copper and the other is sulfur. That is, you have to think, it's a hint. There is the third element which is present is of also oxygen. Now, if you see here, we go to the tabular form. Here if you see, it is elements, copper and sulfur which is given to you. The percentage of copper is given in the next column, that is 39.62 and 20.13. Now, if you total this 2% of copper and sulfur, it comes to 59.75. So there is not, the total is not coming to 100 because percentage is always out of the figure 100. So 100 minus 59.75, the balance is 40.25 and that will be of oxygen. Now, there are three elements present in this compound. One is copper, the second is sulfur, and the third is oxygen. The atomic mass of copper is 63, of sulfur is 32, and of oxygen is 16. Now this is all three columns are tabulated by the given data which is in the column itself. Now the operations start. Divide percentage, that is 39.62, divide by 63, that is atomic mass of copper, will give you a fraction of 0.629. Then the next is percentage of sulfur 20.13 divided by 32, that is the atomic mass of sulfur, which will give you 6.32. There is little mistake here. We will rectify it. 6.29. It should be 0.629. Okay. And the next is oxygen, which is 40% of oxygen is 40.25 divided by atomic mass, that is 60. So that will give a ratio of 2.516. The smallest figure is 0.629. Right, 1 minute. This is different. 32. Okay. The slight correction, that is 0.629. So if you see, you will get copper, the dividing all the terms by the smallest ratio, will get 1, sulfur as 1, and oxygen is 4. So here you will get, here it is, just consider as 0.629, this. So dividing all the terms by 0.629, that is, this is 629, and this is 0.629. So dividing by the term 629, you will get 1, copper as 1, sulfur is 1, and oxygen as 4. And that's why the empirical formula of the same compound is copper sulfate, that is C2SO4 is the empirical formula. If you see here, the empirical formula for copper sulfate solution or copper sulfate is for copper it's 63, that is the empirical formula mass. For sulfur is 32 and oxygen is 16, but there are 4 molecules of oxygen, and that's why 16 fours are. If you total up these two, it comes to 159 grams, which is again given in the problem, that is 159 is the molecular mass of the compound. So this is how you have to confirm whether your answer is correct or not. Now the empirical formula mass is equal to molecular mass, that is molar mass, upon empirical formula mass. So 159 upon 159, the value of R is 1, and that's why the molecular mass of the given compound is R into empirical formula. So the value of R is 1, and that's why it is copper CuSO4. So you get the final answer as CuSO4. So this is the second problem which I had given you homework. So I suppose everyone has got that homework correct. Now I have written 3 more problems. Out of these 3 more problems, the 3, 4 and 5. Problem number 3 I have tried to solve for you. Here it is. That is element, that is 43.4 sodium is a percentage. Now here if you go to the problem, here it is calculate empirical formula. That is a substance on analysis gave the following percentage. That is sodium 43.4, carbon 11.3 and oxygen 45.3. Now you have to calculate only empirical formula. The data is, given data is atomic mass of sodium is 23, carbon is 12 and oxygen is 16. Now here in the textbook they have used directly the data, rounded up the data, I would say. Actually it is 12.008 of carbon, but now they have, in the textbook itself they have written rounded up. So the data is rounded up for convenience, which doesn't make much difference. So the atomic mass of sodium, carbon and oxygen is given. I have given you a hint on each third question. There is a hint of an answer, that is Na2CO3, and in fourth question also there is a hint of an answer, that is CH4N2O. But this fifth question I have not given you any hint. I want you to calculate in a tabular form. Solve this problem in a tabular form. Now here we come to the problem number 3rd, that is the percentage of sodium is 43.4, the atomic mass of sodium is 23. So I start the operation 43.40 divided by 23, the fraction comes to be 1.8869. The second is carbon, and the percentage of carbon is 11.30. So the fraction is, the atomic mass is 12. So 11.30 divided by 12, the fraction comes to be 0.941. And the third element, which is oxygen, which is 45.30. Now here in this case, if you see, there all three elements are given. That's why we need to calculate the total also, which is 100, which I've already calculated and kept. And the operation is 45.30, that is percentage of oxygen divided by atomic mass of oxygen, that is 16. So you get 2.8312. So if you consider all these three ratios, the smallest ratio is 0.941. So I divide all these terms by the smallest ratio, and that's why I get 1.8869 divided by 0.941, that I get the ratio as 2.003. 0.941 divided by the self number, that is 0.941, I get the ratio as 1. And 2.8312 divided by 0.9416, I get the ratio as 2.666. So I have to convert these ratios into a relative whole number, and the relative whole number of 2 becomes 2, of 1 remains as 1, and of 2.6, since it is more than 2.5, we convert to the next whole number, that is 3. And that's why, and the final answer is of the empirical formula of this compound is sodium, there is 2, so Na2. Carbon, there is only 1 carbon, that's why C. And oxygen, there are 3 oxygen, that's why O3. So that's why the answer is Na2CO3. This is the answer of the problem number 3. Now problem number 4 and 5, you please children, you copy down this problem and do it at home. So I would appreciate that you do the homework. This problem is asked in the examination for 4 marks. All these problems on empirical formula, molecular formula. You have to know these problems and you should know the method. You can use any method, but try to solve the problem in a systematical way and to the point. Next, we go to the topic of stoichiometry, which is there. We go to that topic, the next topic, and there are some problems on stoichiometry also, which I have tried to solve for you. So that also we will go and try to finish. But let us understand what is, these are the stoichiometry techniques, or what is the topic like. General problems based on stoichiometry are of the following types. There are different types of problems based on stoichiometry. One problem is problem based on mass-mass relationship. Mass and mass relationship. The second problem is problem based on mass and volume relationship. And the third type of problem, which is C, is problem based on volume and volume relationship. So there are 3 different types of problems. One is mass and mass relationship. One is mass and volume relationship. And one is volume and volume relationship. So there is not much difficulty to remember this. One is mass-mass, one is mass-volume, and the other is volume-volume. That's all. So we will, what are the steps we should know, the steps which are needed for this, what are the steps needed for solving these problems. So steps involved in problems based on stoichiometric calculations. Very simple, there are 4 steps which you should know. First off, important thing is, you should write down the balanced chemical equation. The equation is that the reaction, the chemical reaction, you have to write down in a balanced form. So write down the balanced chemical equation representing the chemical reaction. So this reaction has to be written down in a balanced form, very important. Then on the basis of the data, what we know earlier is the atomic weight of carbon, atomic weight of, I would say atomic mass of carbon, is 12, atomic mass of hydrogen is 1, atomic mass of chlorine is 35.5, atomic mass of oxygen is 16, atomic mass of nitrogen is 14. All this data which we have used earlier, you should know it by heart. So, second is write the number of moles and the relative masses or volumes of the reactants and the products below the respective formula. Once you come to solve one problem, you'll come to know the solving of this methodology. The second is relative masses or volume should be calculated from the respective formula mass referring to the condition of STP. So this is what I have told you, the atomic masses of different elements of carbon, hydrogen, for example, carbon is 12. That you should do. Then the next step is apply the unitary method to calculate the unknown factors as required by the problems. So these are the 4 methods to calculate or to solve problems of, that is, of stoichiometry calculations. So first you should know the type of reactions, type of the problems, and the second is the method of to solve these stoichiometric calculations. We come to the problems. Here it is, the data is given to you in this problem, that is carbon, hydrogen and oxygen. These are atomic masses of carbon, hydrogen and oxygen, that is 12, 1 and 16 respectively. Now here it is calculate the mass of a carbon dioxide, CO2, and water formed on complete combustion of 24 grams of methane gas. Now my problem is 24 grams of methane gas. I have to calculate for of complete combustion of 24 grams of methane gas. Now here the atomic mass is given as I told you. Now how will I solve the problem? The balanced chemical equation. First, what is the important thing is I have to write down the balanced chemical equation. So methane, that is CH4 gas plus 2 molecules of oxygen gas. Here there is an arrow, I was not able to write down this arrow, gives you CO2 gas plus twice water molecule. Okay, H2O gas. If the water molecules means, when I say water means it is a vapors. G means vapor. Now CH4. Now how am I going to write CH4? Now atomic mass of carbon is 12, so I have written 12. Plus it has got 4 hydrogens, so each hydrogen is 1. So 12 plus 4 is 16 grams. So got the method. Second, 2 molecules of oxygen. Now 2 is outside, you have to multiply 16. 16 is atomic mass of oxygen, but there are again oxygen has 2, O2. That's why 16 to the 32. 32 into 2, 64. That's how I got. The next is CO2. Carbon is 12 plus oxygen. How many oxygen? 16. Oxygen as a molecule means O2. 16 to the 32. 32 plus 12, 44. And finally water. 2 molecules of water. 2 multiply into bracket. Hydrogen there are 2. So 1. 2 ones are 2. 2 plus oxygen 1 molecule. That's why 16. 16 plus 2 is 18. 18 to the 36. So finally I got 16, 64, 44 and 36. Hence 16 grams of CH4 on complete combustion. Here it says 24 grams of methane gas. So 16 grams of CH4 on complete combustion will produce 44 grams of CO2. CO2 is here, 44 grams of CO2. So when I use 16 grams of methane on complete combustion, I will produce 44 grams of CO2. Therefore, 24 grams of CH4, if I take 24 grams of CH4, how much it will consume, how much CO2 will be produced? So that is 24. Since I am calculating for 24, divide by 16 into 44. Why I am taking 24 grams? Because 24 grams of complete combustion of methane. So 24 divided by 16 upon, that is of methane, into CO2 44. So when I divide 24 by 16 into 44, will give me 66 grams of CO2. So for 24 grams of methane, I will get 66 grams of CO2. If I see 16 grams of 16 grams of methane, I will get 44 grams of CO2. So for 24 grams, I will get 66 grams of CO2. Similarly, 16 grams of CHO will produce 36 grams of water. Similarly, 16 grams of methane will produce 36 grams of water. Therefore, 24 grams of CH4 will produce how much water? So, 24 divided by 16 into 36. Since it was for 16 grams, I was getting 36 grams of water. So, for 24 grams of methane, how much water I'll get? I get 24 divided by 16 into 36, that is 54 grams of water. So this is my final answer. One is I will get, for 24 grams of methane, I will get 66 grams of CO2, and for 24 grams of CH4, I will get 54 grams of water. So this is one problem which we have tried to solve. So here, and the next problem which is there is how much CaO will be produced by decomposition of 5 grams of CaCO3, that is calcium carbonate. So the answer is calcium carbonate decomposes according to the valence equation as follows. So calcium carbonate CaCO3 is an arrow, give you delta CO plus CO2 gas. So here, so this line is an arrow, please consider this an arrow. So calcium carbonate gives you CaO and CO2. Definitely this is on heating, this delta should be on top of the arrow. So now calcium, what is the atomic mass of calcium? 40. What is the atomic mass of, first step was to write down the valence equation. So we have written a valence equation. Now after writing the valence equation, the second we have to write down, calculate what is the atomic mass of this calcium carbonate on the basis of the data which we know, that is atomic masses of each element. So you have to see calcium, the atomic mass is 40, for carbon is 12, for oxygen is 16. So there are 3 oxygens, that's why 16 threes are. So 40 plus 12 plus 16 threes gives you 100 parts. So I've used the word 100 parts now, since 100 grams also I can use, 100 parts, okay. The next is CO. For calcium, atomic mass is 40, and for oxygen, the atomic mass is 16. So 40 plus 16 is 56 parts. The next is CO2. So for calcium, it is 12, for carbon it is 12, and for oxygen is 16, and see there are 2 oxygens, 16 to the 32 plus 12, that is 44 parts. So calcium carbonates I get 100 parts, and calcium oxide I get 56 parts, and for carbon dioxide I get 44 parts. So 100 grams of calcium carbonate produces 56 parts of CO. So how much CO will be produced by decomposition of 5 grams of calcium? Therefore, 5 grams of calcium carbonate will produce 56 grams, that is for 100 grams, so 56 grams divided by 100 grams into 5 grams. So that will be 2.8 grams of calcium carbonate. So this is the second answer of the problem on stoichiometric. So we have tried to solve 2 problems on stoichiometric. My dear children, one thing I'm going to tell you is whatever topic is in the syllabus that I am teaching you on, whatever is not in the syllabus, I am not teaching you because for this year, due to the pandemic, the syllabus is reduced for 11th as well as 12th. So whatever is in the syllabus, that part I am teaching you on. So just for your information. So my dear children, I hope you are able to understand whatever I am teaching. So try to practice the problems, all are molecular formula, empirical formula, also in stoichiometry, whichever we have discussed in the classes. So last 3 lectures we have studied problems on molecular formula, empirical formula, and today we have studied a new topic that is stoichiometry, and we have tried to solve 2 problems. So try to solve the remaining problem on your own, referring the textbook, and definitely try to take care of yourself. Study hard, stay home, and stay safe. Thank you. Bye bye. Have a good day.